Angles. Angles are made up of two rays that share a common endpoint. This common endpoint is also called a vertex. There's a vocabulary word for you. Now, angles are named by calling them out by the letters that are indicated on the rays. For example, this is angle A, B, C. Two things for you to notice. The small angle symbol that is in front of the letters A, B, and C. And notice that the letter B is in the middle of the letters A and C. Two things to notice. The letter B being in the middle indicates that that is where the vertex is. So whatever letter you have down here at the vertex of the angle, down in this region right here, that letter has to be in the middle. And it doesn't matter whether you call it angle CBA or angle ABC, but B has to be in the middle. Now, this area, this region that I'm shading in here in the picture, this is the interior region of the angle. It is bordered by the two rays that make up the angle. When we are talking about an angle's measure, we're talking about the number of degrees in that shaded interior region. So for this particular angle, you can tell it's less than 90 degrees. I could say that the measure of angle A, B, C, and if I measured it with a protractor, quite likely might be 86 degrees. I also have an option of calling this angle out by numerical name. Let's say I put the number 2 in the interior corner of that angle. I can then, as I'm working math or talking about the picture, I can say the measure of angle 2 equals 86 degrees. Angle 2 and the measure of angle ABC, that's all the same figure. Now let's take angle PQR. And again, I'll review, the letter Q has to be in the middle because it is the vertex point or corner. All right, so let's say this angle simply has another ray that's in its picture. Now, when I put this ray in here, if you notice, as I move it like right about there, it looks like it divides the angle dead in half. This is called bisection. We'll look at that in a minute. The ray could be like this, where it's closer to the ray QR, creating a smaller piece, or it might be over this way, but nonetheless, we have this third ray involved in this picture. And let's say this ray is called QS. Now what QS is doing is it's creating two smaller angles, one of which is larger than the other. I think you can tell by the coloring of these angles as I've shaded in the interiors of each of the smaller angles that ray QS divided angle PQR into that they're not equal. But if you keep them together, does it make sense that this angle from P to S, and if you add the angle from S down to the other side, if you add them together, don't you have the entire larger angle measure? What this is, and this is called angle addition. And it allows us, just like it did with segments, to write an equation. So I could say that angle PQS plus angle SQR equals the great big angle, angle PQR. This is called angle addition. Another way to write this equation format and it's a little quicker sometimes if you're having to think and do multiple steps in a problem, I could actually put numerical values in the picture itself. For example, I could put a 1 right there. I could put a 2 here. And then I could say angle 1 plus angle 2 equals angle PQR. And it just allows me to write and think a little faster. They're both completely legitimate. And if these numbers are actually placed in the picture, which you can do, or maybe it comes that way, then you can use that version of the equation. Now here we have angle XYW, angle XYW, and I'm going to add in a third ray, yet again. But this time, the ray isn't going to be closer to one side or the other. It's going to go straight up through the middle of that picture. And we'll call this ray YM. When it goes dead through the middle of the angle in the interior, it's actually creating two smaller angles that are equal. When this third ray shows up right dead in the middle, this is called angle bisection, and it is a bisector, and what it's doing is it's creating the blue angle equal to the yellow angle, and you can mark it like that. Those are called congruence marks. So there it is again. Congruence. The geometry symbol for congruence is the equal sign with the squiggle above it. It means in the picture we have some parts that are equal size and shape and measure. Okay, now the equation that this will give you would be angle, now watch where I'm pulling these from, X, Y, M, see the little blue angle, plus angle M, Y, W. If you add those two together side by side, and by the way, there's a word for side by side, it's called adjacent, A-D-J-A-C-E-N-T. Adjacent means side by side. The blue and the yellow angles are side by side, so blue plus the yellow equals the larger angle X, Y, W. And when you look at this picture, that should make sense. But the really special thing that happens when this takes place, when you have that third line segment that goes right up through the middle, and it's just like with line segments, is that the blue one, angle X, Y, M, is equal to angle M, Y, W. And we could do the blue plus the yellow equals the big one. But this is the big deal when you have angle bisection going on. It's very important. Okay, let's recap what we have with angles. It's very similar to what we had with line segments. When you have an angle that has a third ray involved, splitting that angle into not necessarily equal parts, but definitely two smaller pieces. And let's say the big angle is called A, B, C. And we'll call each little angle, we'll call one of them angle 1 and the other angle 2. I'm going to use the shortcut version here. If there are no congruence marks, remember congruence means same size and shape, then you can't count on anything being equal. I don't care what it looks like. If it's not marked as congruent or as a bisection, you can't go that route. You're going to work an equation like angle 1 plus angle 2 equals angle A, B, C. This is the format of piece plus piece equals the whole thing, the whole big angle. And as mentioned earlier in the line segment video, this is one of our frequent equation formats that we have to then work and solve. The other situation is if you have an angle, let's take an angle R, S, T, and the third ray shows up right through the middle of it. And it might even be a really bad drawing, but someone has marked it as congruent. And let's call this angle 3 and angle 4. We could say angle 3 plus angle 4 equals angle RST. But because it's a bisection, more than likely you're going to say angle 3 equals angle 4. And this is in the format of piece equals piece. Now, bisection usually means it's going to be piece equals piece, but every now and then you're still adding up the two smaller pieces to get the larger one. And again, these are the two most frequent equation formats that we deal with our beginning figures in geometry. Oh, and don't forget the word adjacent. Do you remember what that means? Adjacent is when you have two figures that are side by side. Like the angles, the smaller angles in both of these pictures. When I look at these pictures, this over here, this small angle 1 is definitely side by side with angle 2. Likewise, in this picture, angle 3 is definitely adjacent to angle 4. Side by side, they don't overlap, there's no gaps. That's the vocab word, adjacent. Now go to your example videos on angles, angle addition and angle bisection, and make your way through those before you practice. Because there's more to angles than just these two. We'll see you soon.